Welcome to The Explainer. Today, we're pulling back the curtain on a classic digital heist. It's an attack that doesn't kick down doors, but instead it cleverly turns a network's own trust into a hacker's most powerful weapon. So, how can just one person secretly read an entire network's traffic? I mean, it sounds like something straight out of a spy movie, right? But it's totally real. The answer lies in exploiting a fundamental protocol that your network relies on every single second of every day. All right, so here's our game plan. We're gonna walk through this digital heist step by step. First, we'll find the flaw in the system. Then we'll cover how to become the middleman. We'll get into the art of deception, explore the hacker's playground of possibilities, and then, crucially, we'll learn how to build the fortress walls to stop them. Okay, let's get right into it. Every great heist, digital or otherwise, needs a weak spot, a crack in the vault, right? And in our case, that vulnerability is a protocol that was built on, well, a foundation of pure trust, long before we could even imagine how badly that trust could be broken. So what is this protocol? It's called the Address Resolution Protocol, or ARP. The easiest way to think about it is like it's the network's own personal address book. See, your computer might know another device's IP address. Think of that as its name. But to actually talk to it, it needs its physical hardware address, the MAC address. ARP is basically the little messenger that runs around matching those names to physical locations. And this right here is the fatal flaw. ARP is, well, it's just way too trusting. It's like that person who believes literally anything anyone tells them, no questions asked. There's no authentication, no ID check. Anyone on the network can just shout, "Hey, that router you're looking for? Yeah, that's me now." And every other device on the network just goes, "Okay, cool," and updates its address book. Seriously. So when you have a vulnerability that big, the attacker's goal becomes surprisingly simple. They just need to become the invisible switchboard operator for the whole network. All right, let's set the stage. We've got three main players in this little drama. First, you have the victim, just minding their own business, browsing the web. Then you've got the router or gateway, their connection to the big, wide internet. And then there's the attacker, sitting quietly on the very same network. Okay, so normally traffic flows in a straight line, right? The victim talks directly to the router and the router talks directly back. Simple. The goal of this attack is to totally change that path. We want to secretly wedge ourselves right in the middle, so all that communication has to pass through the attacker's machine first, and here's the key part, without either of the other two having a clue. So how is it done? This is where the real art of deception comes into play. The execution is this brilliant two-part lie that happens at the same time. It's called ARP poisoning, or ARP spoofing. The first part of the lie is aimed directly at the victim. The attackers start sending a constant stream of fake ARP messages. These are called ARP replies, straight to the victim's computer. And we're not talking one or two messages, it's a flood, just to make sure the lie sticks. And what's the lie? It's simple but powerful. "Hey victim, you know that router at 10.0.1.1? Yeah, well, its physical address is now my MAC address." The victim's computer, thanks to that trusting nature of ARP we talked about, just accepts it. It overwrites its address book, and from that moment on, it thinks the attacker's machine is the router. But that's only half the job. At the exact same time, the attacker is sending another stream of lies, but this time, the target is the router itself. And this lie is the mirror image of the first one. "Hey router, that victim over at 10.0.1.25, any data you have for them? Yeah, send it to my MAC address." The router, just as trusting as the victim, updates its records. And just like that, you've completely fooled both ends of the conversation. Okay, so with both the victim and the router completely tricked, the attacker now controls the entire flow of information between them. They are officially the man in the middle. Welcome to the hacker's playground. This is the new reality of the network. The attacker's machine has become what's called a transparent proxy. Every single piece of data the victim sends out to the internet and everything that comes back now flows right through the attacker's computer. And as long as they keep forwarding that traffic along to its real destination, nobody is the wiser. So what exactly does this get the attacker? Well, they now have a front row seat to the victim's entire digital life. We're talking any unencrypted web traffic, DNS queries so you know every site they're trying to visit, session cookies, and any passwords sent in the clear for older protocols like FTP. You can even figure out what kind of device they're using, like an Apple or a Dell, just from the MAC address alone. But just watching is kind of passive. The real power comes from being able to change the data. Now the attacker can do all sorts of nasty things. They can hijack sessions by grabbing those login cookies, send the user to a fake banking website to harvest credentials, or even swap out a legitimate file download with a piece of malware. It's total control. Okay, that sounds pretty terrifying, right? And it is. So the big question is, how do we possibly defend against an attack that's so powerful? An attack that exploits the very foundation of how our local networks are supposed to work? Well, the good news is we are not defenseless. Modern networks don't have to operate on blind trust anymore. There are several layers of security that can be put in place, specifically designed to spot and shut down this exact kind of deception. The best defense is really a layered defense. You can start with something called static ARP entries. Think of this as manually writing the router's address in permanent ink in your address book, so it just can't be changed. On a bigger scale, network switches can use a feature called dynamic ARP inspection. This thing acts like a bouncer, checking every ARP message against a list of approved devices. Then there's the big one, encryption. Using protocols like HTTPS means that even if an attacker does manage to intercept your traffic, all they get is a bunch of unreadable digital garbage. And finally, you've got intrusion detection systems. These are like the network security guards, constantly patrolling and programmed to spot suspicious ARP activity and sound the alarm. So, look, understanding how this attack works is incredibly powerful. It gives you a deep insight into network security, and it's essential knowledge if you're in cybersecurity. But, and this is a big but, with that knowledge comes a really serious ethical responsibility. Yeah, there is a crystal clear, non-negotiable line between using this knowledge for good, for learning, for authorized security testing, for making networks stronger, and using it for illegal activity. This isn't a gray area at all. So what's the bottom line? It's actually really simple. This stuff is only legal and ethical on networks that you personally own, like a home lab setup, or on networks where you have explicit written permission from the owner to conduct a test. Trying this on a public Wi-Fi at a coffee shop, at your school, or at your workplace without authorization, that's illegal. And the consequences are no joke. We're talking everything from getting fired to facing actual criminal charges. And that really brings us to the final thought. This whole thing isn't just some abstract, theoretical exercise. ARP spoofing exploits a fundamental part of how local networks were designed to function. So now that you know the flaw, it kind of makes you wonder, doesn't it? How secure is the network you're on right now? Understanding this is the first step to really grasping just how vulnerable we can be. And it highlights why modern defenses, especially encryption, are so incredibly critical in our day-to-day lives.